In this video, we introduce precipitation reactions, which is one of the three classes of reactions that you can find in solution. Precipitation reactions are those in which you mix two soluble species, two or more soluble species, and then a reaction takes place that generates an insoluble species, which we call a precipitate. Right, so let's write an example for a precipitation reaction. We're going to be mixing calcium chloride, which is soluble, okay, and we'll write here parenthesis AQ, which means that there is a soluble species in water. Okay, so this is going to be a water solution. Okay, we're going to mix this with sodium carbonate, which is also a soluble species, okay, in water. And when we mix these two species, ionic solids, a precipitate forms. Something insoluble is going to form, and that product that is insoluble is calcium carbonate. It's a solid, okay? And then the other product that you can form would be sodium chloride. Okay. Sodium chloride, table salt, as we know, is water-soluble ionic solid. Okay, but calcium carbonate is actually not soluble in water. Calcium carbonate is part of, for example, eggshells. It's the solid that you have predominantly in eggshells. Okay, so we understand that it is not soluble. So when you actually have calcium and carbonate ions in solution, they get together, form an ionic solid, and they precipitate out of solution. Okay, so notice that what the ingredients are for a precipitation reaction. You need soluble species reagents, okay, and then you need at least an insoluble product. Okay, in this case, the other product happens to be soluble. Now, well, this is called the molecular equation. Molecular. This molecular equation actually only tells us the main players in the reaction, but it really doesn't tell us why the precipitation reaction takes place. Okay, to actually take a look at that, we're gonna write now what is called the complete ionic equation. Okay, as it turns out, calcium chloride is a solid, say an ionic solid, but when you actually put it in water, it dissociates into the constituent ions. Okay, so in reality, what you actually have in solution is going to be the following. Okay, I'm going to write here the complete ionic equation. Okay, so what you have in solution is that calcium chloride dissociates into calcium 2+, which are soluble, and two ions of chloride, which are also soluble, and then sodium carbonate, okay, is going to dissociate into sodium ions, which are soluble, and then a carbonate ion, which is also soluble. Okay, and then you're going to get products, which I'm going to write it down here. Okay, these are all the reagents in ionic form. The product is going to be calcium carbonate, solid. Notice that I'm not writing this in ionic form because it's actually not soluble. When you have calcium carbonate like you have in an eggshell, okay, that calcium carbonate does not dissolve in water appreciably, so you don't have calcium 2+ and carbonate 2-. Instead, you have the solid. That's why we write it in this solid form, and that is the key. Right, and then the other product is going to be sodium, 2 of them, and then chloride, 2 chloride. And here we have to write here. Okay, so this actually tells you a little bit more about what happens at the molecular level. Okay, when you mix these two soluble solids together in water, okay, you have a variety of ions that are released. Okay, some of those ions are actually able to react with each other to form a very stable solid that again crashes out of solution. Okay, so that is actually what's indicated here. Now, interestingly, what we can actually see in this complete ionic equation is that there are ions that appear both in reagents and in products. For example, if we take a look at this chloride, okay, you have 2 chloride in reagents and 2 chloride in products. And for the sodium ions, you actually have exactly the same. Okay, so notice that these ions actually do not participate in the reaction at all. Okay, they're in reagents free in solution, and they're in products free in solution. They don't intervene in reaction at all. Okay, so these ions that actually don't form part of the overall precipitation reaction are called spectator ions. Okay, spectator ions. Okay, so then to hone in a little bit better into what really is going on into these precipitation reactions, we can write something that's called the net ionic equation. Which is the same thing as the complete ionic equation, but with the spectator ions removed. Okay, so as you can see, that is going to tell you what really goes on in solution. So you have calcium 2 plus combining with carbonate 2 minus. Okay, and these ions are going to interact with each other electrostatically very, very strongly, and they're going to be a fallout of solution. Okay, to form a solid calcium carbonate. Okay, so that is the net ionic equation that is the key of what's going on in this reaction. Of course, in order to be able to predict what product is going to be soluble and what product will be a solid, we actually need to make use of something that is called the solubility rules of ionic solids. Okay, now those solubility rules are in a table in your book, table 4.1. Okay, and that's something that you don't need to memorize because it's something that will be provided to you if you need it. Okay, but the solubility rules give you a good guidance for how to identify what of the species will be soluble in water and which ones will not be soluble in water. For example, most nitrate ionic solids are actually soluble. Okay, so it's very hard to form a precipitate with nitrate. Okay, most sodium salts are also soluble. Most potassium salts are also soluble. And then we have that, for example, most chloride salts are soluble, but there are some exceptions. For example, silver chloride is not soluble, and lead 2 chloride is not soluble. Okay, so there's those solubility rules with which you can predict whether a precipitate will form and what will be that precipitate that forms in this precipitation reaction. Now, when talking about precipitation reactions, we're also going to be doing quantitative problems, and for example, the type of problems that we may be doing is as follows. Suppose that we carry out this reaction and we can measure the mass of calcium carbonate that we actually are obtaining from the solution. Okay, from the mass, if we know what the species is, we can get the number of moles, and then typical questions that we can ask is, well, what was the molarity of some of the reagents that led to that product? Okay, so we can also do stoichiometric type of problems with these precipitation reactions, and that's something that we will be practicing with. Okay, so in this video we have introduced the concept of precipitation reactions, and we have written molecular, complete ionic, and net ionic equations.